Hello! Today we have this nice HP laptop. It's what is it? HP Pavilion laptop model 15-CW1310NG. So this device came in with no power. So when I press the button, nothing happens. No light, nothing. So let's check what we have here. Charger. Oh, and we actually do have charging light, which is weird. Maybe not. Okay, pressing the power button. Oh well, I have light. I have light on the power button, and I have picture. Okay, I have no idea what's going on with this one, but seems to be working right now. I think I'll leave it at the charger for a few hours, and when I'll check again. Okay, good. Power down. Very disappointing. Okay, put it. Now, where do we put it? Here. Here is it. Okay. Well, then we have to move to the next one. I have a second one. A second laptop. This is the Lenovo Yoga. Lenovo Yoga C930-13IKB. As far as I know, a very, very expensive workstation business laptop. However, for office, it is a bit used, but it looks very, very nice, to be honest. So let's check. Also, no power. No power issue. Let us check with the USB-C charger. I have this nice tool here, which tells me something about the voltage and the consumption. Can you see it? KWS minus 1902C. Very useful tool when we have to deal with USB-C devices. Okay, we have 20 volt. So the 20 volt are indeed requested. Pressing the power button does nothing. Also no change in consumption. Long press, also nothing. Okay, I think we can open it. Oh, water damage? I think I can notice water damage. WLAN card is also missing. SSD is missing. I think we have water damage here. Let's check under the microscope. Here, what's this? Oh, Oh, this is not good. And near the CPU. Okay. I think I was scammed. Here was clearly someone was here working at. Here, look. These are marks of someone was doing some things here. Ah. Which controller is it? For memory? No idea. Can be anything. Can't tell right now. Okay. However, we have to we remove the board and have to figure out what we deal here. I think I have even noticed more water damage here. Here. Oh my god. Is it water damage or not? What is it? It is water damage, no? Okay. I think we do some checks before we remove the board. At first we disconnect the battery. But I can't. I can't easily. No, okay. Better than nothing. Good. Okay. So, resistance checks. Mega ohms. Okay. This is near processor. 10 ohms. Sounds good. Another near processor. 7 ohms. So this is probably VCC GT and this is VCC core. These two phases here. So what else? Maybe for charging, no, but it's too small for charging. I think it's too small. 20. This could be VCC System Agent SA. VCC SA, maybe. And this one, 106 ohms. This is likely the PCH. 1.05 supply for the PCH. And so this one is very likely for memory. It's still good. 186. Okay. So what? Only issue. What is the issue here? We have to clean this all, of course. This could be the main power rail. 4. And we have also liquid damage here. I'll show you later. Kilo ohms, probably likely 5 volt or 3.3. And we have another coil here. Also kilo ohms. We have another one here with kilo ohms. And another one here with kilo ohms. So resistance measurements looking fine, actually, which is a bit surprising. Okay, but we really have to inspect the liquid damage here and to clean it, of course. So we remove the board. I'm not sure how this was possible. However, liquid clearly went inside. I think we have even something onto the CPU. But we don't have shorts at this point, so maybe, with some luck, the power cut even before these rails. So yeah, maybe even the main power rail isn't present. And I'm not talking about the 20 volts which we measured at the connector. These 20 volts goes into a circuit and will be stepped down to a lower voltage, and for creating the main power rail from where? Probably or likely something around 10 volts, plus minus. Okay, so it can be, okay, well, we have no short, but something is interrupted. Probably. Maybe even just a bad MOSFET, a DC in MOSFET, a bad one. Can be. We'll check. At least it is very good that no power went into this board after this accident. This is very good. Otherwise, it would be probably already a no fix. Okay. No water damage on keyboard side, but here we have water damage, or just the corrosion. We have corrosion here. Here, I'll show you. So this is the back side. What do we have here? Here. Look at that. Look, what is it? I'm not sure whether this is audio circuit. This is the AMP controller, IT 8227 VG-192 BXO. Okay, I hope I don't have to mess with it. So here, when we have also, yeah, okay, but here is more important. Here, what's more damage? So we have to carefully inspect the whole board for water damage here. Here. Clean it. And then we pour it on and see what happens. Okay? Okay, charger. 20 volts. Power button. Nothing happens. Nothing happens. Board stays cold. This rim is attached. Did we miss something? Something important? Don't think so. Okay, we check voltages. To look where it is stuck. So we already know 20 volts are present. What about the main power rail? Nothing. Main power rail isn't created. Here we have nothing. Nothing. Okay, I can't measure any voltage here. Okay. Here, nothing. So power comes here. 20 volt here. Okay, it seems I was wrong with the charting controller. I just opened the schematics and I have to check pin 1. So we check again for power. So we don't miss anything here. So ground, and this is pin 1, and we have still no power. Still no power. Okay. Resistance to ground. We'll check resistance to ground first. Now what do we have here? It's not much. We need a better ground point. Oh, it is shorted with 3.7 ohms to ground. AD in is shorted. For this reason we don't get power. This is pin 1, isn't it? It is pin 1. And we have 3.6 ohms to ground. This is a short to ground. And now we have to find out what causes it. PR50. Where is PR50? PR50. Is it here? This area? No. 53. PR50 is here. Here. So I should measure the short again here. Here. Yes. 2.4. Internal resistance of the probes is 0.4. So we have a 2 ohms short, actually. So what is it? We inject voltage. We make it short and inject voltage. We come with 1 volts. 1 volts. To be careful, 1 volts. Let's say 1 amps to start with. Okay, this was 10 amps. Don't want so much. 2.5. So 1 amp, this is good. And now we try to find the short. Simple, no? Inject in. So, and it was have to be careful to not bend the board too much. It is very thin board, and I don't want it to bend so much. Where is it? Here. So I hope it is one of the caps. Don't get above 1.2 amps. I think it is in this area here. If I remove this fuse, I can cut the rail in 2 parts, and maybe we can check this way where is the short. Maybe it is not necessary. Okay, so if I'm in the correct direction, I can measure a short here. Yes, I have a short to ground here. The fuse is still intact. So where could be the short? Where could it be? F4. Oh yes. Something is definitely warming up here. I'm not sure which cap is it. I think it is one of these caps. Is it the fuse? We try the caps. We try the caps. Maybe we are lucky. Okay? This was 1 volt, 1.2 amps, and I already can feel something. So you see, it isn't necessary to inject even 19 volt there, because usually it is a bad idea when you don't exactly know what you are doing. In bad cases, you can inject these 19 volt directly into the CPU, which is supposed to run with only 1 volt. I think you can guess yourself what will happen in this case. So, however, we have a shorted cap, which is interesting. So much damage, and we have just the shorted caps. Just shorted caps. It is very weird. Very, very weird. So this one here. The board is thin. I think we can lower the temp a bit. Maybe for 30 degrees Celsius. Oh, this is too much airflow. Less airflow. The big one. I think it is a big one here. So remove from the circuit. We check for resistance to ground again. And we have still 3.8. Okay, so it is still shorted. So the next one, please. Yeah. It is in this area. I'm sure. Check again. Resistance to ground. And oh no, it is still shorted. Why? What is it? Is it this big cap? No. No. Is it the chip? Is it the IC? What is it? Okay, back in place. Okay, good enough. What else do we have here? Yeah, well, nothing else. Where are these two caps? And then there is the APL controller, which is possibly dead. Can't be anything else, I would say. Okay, we just remove straight and fast U38 because it must be the culprit. Must be the culprit. Yep. Good. So now, resistance to ground. Come on, please. And we have mega ohms. It is the controller, it is the APL controller. We probably have to continue later because I have to source this IC, this APL IC. And when we see what's going on. Okay,